Okay, we're still working on BC Multiple Choice 2008. It's 1 o'clock, so I'm going to try to stop at 1:30. Okay, the above polynomial, the polynomial function has selected values of its second derivative. Okay, I see that. Given in the table, which is following statements must be true. Increasing, decreasing, local max, local min, point of inflection. Okay. Changes concavity in the interval. Okay, I'm looking at D and E at the moment because they're mentioning second derivative. So let me make a second derivative number line. Okay, second derivative number line. Now it's saying at 0, it's positive. And at 1, it's 0. And at 2, it's -7. And at 3, it's +4. Okay. I just don't know if the whole sections it's that way. Oh, okay, I don't know where to pause on my new video system. Okay, so I'll have to find pause in case I need to sneeze again. Okay, so changes concavity in the interval. Well, let's take a look. So at 0, it's positive. And at 2, it's negative. So it seems like it's going to have to get from positive to negative. Now it is a polynomial. So polynomials means everything's smooth and curvy. So there's no problems with like jumping or gaps in the derivative or the second derivative. So I would say everything's all smooth and happy here. Point of inflection at specifically 1. Okay, so I like both of those. If D were true, okay, so if we went with true for D, it's not true. But if we went for true for D, it's possibly true. Saying that, and let me fill in our maybes in red, and saying that everything up to 1 was still positive and everything after 1 was still negative. Well, then yes, D would be true. But it would also change concavity for E. Well, I can't have 2 of them true. So D can't be true, mostly because if D were true, E would be true too, and we would have 2 answers. Okay, so that's one reason. But the other answer, that's the logic reason. The math reason is what if right here it was, maybe there was another point of inflection over here at 1/2, 0, and it was plus, plus, negative, 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 negative. Then 1 is not a point of inflection. This would be positive concavity, negative concavity, negative concavity. So 1 would not be a point of inflection. So that is a counterexample. Okay, so that's a counterexample for this one. So that is a counterexample. So let's see, 0, 1, 1/2, 0, 0, plus, plus. Oops. We said that was going to be minus, minus. Okay, we're going to have this be minus, 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 minus. Okay, and then this was plus, plus, plus. Okay, so there is my counterexample for D. I like E. Local max. What would concavity do with a local max? I don't feel like concavity has to do with local maxes. Decreasing and increasing, they don't have to do with second derivative. So I think that A, B, and C would be very difficult. Now, can I make it so E is not true? So let me try to make E not true. So this is actually false because of my counterexample. How can I make this false? How could I not make it change? I can't. I'm trying to think. So 0 is plus, and then at 1 it's a 0, and at 2 it's minus. So it's a polynomial, so it can't be a horizontal line. It can't have positive concavity in some places and then have horizontal lines somewhere else. So at some point, this would have to go to 0. You know, and then it's all minus. This is all minus. But this would be a point of inflection, and that would be in the interval from 0 to 2. So I'm convinced it's E. If you need more convincing that A, B, and C are not true, just let me know, and I will make a video just about that problem. Okay, number 15. Number 15, I kind of like blue. Okay, so number 15, I need to take the derivative. That is the chain rule. Okay, except not like that. So that's the chain rule to the 1, and then you're going to have to multiply it by the derivative of the inside. So you keep the inside the same, and then multiply it by the derivative of the inside. My times 1 is I like to take the derivative of the inside of the ln of x, but that one's not necessary. And then let me rewrite it. F prime of x equals 2 ln x over x. I think I'm going to use the quotient rule. So f double prime of x is, let's see, denominator times the derivative of the numerator. So that would be 2 times 1 over x times 1 minus, remember you have a minus in the quotient rule, numerator 2 ln x times the derivative of the bottom x, which is 1, and then over the bottom squared. I'm not sure if you learn this way, but sometimes at Walnut we go low d high, I think it's called, and then minus high d low over low low. So if you learn that way, that's cool too. I just use the words. Okay, but I like having ways to remember it, but that one for me, it hasn't stuck. Okay, so this is 2 because those x's cancel, right? This x and this x, they cancel. And then this is 2 minus 2 ln x over x squared. That is f double prime of x. And then I need to substitute in rad e. So the second derivative at rad e is 2 minus 2 ln rad e over rad e squared. And remember, you want to show all your work. One, because this year we're having the AP test only free response in 2020, but also because you're going to have, everybody has free response on every year, right? So you never know where this one's going to come up. Square root is a 1/2 power. The 1/2 comes in the front. So you get 2 minus 2 times a half ln e over e. And remember, ln e is 1. And so that is 2 minus, those cancel, 1 over e, which is 1 over e. And 1 over e is answer choice A. This right here doesn't really look like an equals, so let me make sure that's real clear. This is a line, this is an equals. There we go. Okay. Let's go to the next one. These are standard. I think you'll be good at these. So these are pretty good. Just waiting for a second in case you need it. You can always pause and rewind. We'll go to the next question. Okay, so this is 16. What are all the values for which this converges? Okay, I would say this is not on this year's test, but it's on other tests and you might need it for college. So I'm gonna do the problem anyway. Okay, so limit, this is an interval of convergence is what it's called. So limit as n approaches infinity. You do the ratio test usually, but I'm going to do the nth root test. Okay, the nth root test is better for this one, I think. So this is the nth root test. Usually for intervals of convergence, you do the ratio test, but the nth root test in this case is going to work out better. 2 over, and then usually we just slap an absolute value on it right here. Okay, but we don't need it because x squared plus 1 is positive. Okay, so, and it might be on the test because convergence is, but I don't think nth root test is, so maybe not. Okay, so for this one, now it's n approaches infinity. So there's no n left. So be careful not to substitute n in for x. Interesting. So that's this. So this is actually rho. Yeah, it's definitely n approaches infinity. Okay. That's interesting. There's another way. So this could be on the test as well, because I just thought of another way, and I'll tell you that in a minute. this has to be between 1 and negative 1. Now, normally multiplying with an inequality, you do have to be careful, like cross multiplying is a concern, but x squared plus 1 is always positive. X squared plus 1, so it doesn't change the inequality sign. X squared plus 1. This is very, I don't like how I'm solving it. I might change my mind in a minute. 2 is less than x squared plus 1. I'm going to just separate them. Negative x squared minus 1 is less than 2. X squared greater than 1. Square root, absolute value. X greater than 1 or x less than negative 1. This one, negative x squared is less than 3. Divide by negative, x squared is greater than negative 3. Yeah, that's always true. X squared is always greater than negative 3. But I also, this is an and, I also need this to be true. And then I need to check the endpoints. It's very odd. I have to check the endpoints to see if they work. I kind of want to redo this question. I'm feeling this is geometric. Okay, this is geometric. I feel like it's geometric. And I feel like r is 2 over x squared plus 1. Okay, so I'll solve that another time like this, but then that would still say that this has to be, absolute value has to be less than 1. So that's still the case. But that does allow me to flip it. So if you don't like the way I solve the inequality, we could actually come back and throw an absolute value, the one I was discussing, over here, over here, over here. But instead of doing what I did here, we could go like this. Flip it. Now remember, when we flipped, it changes the direction of the inequality sign. Okay, and then multiply both sides by 2. And then x squared greater than 1. And then square root both sides. Absolute value of x greater than 1. X greater than 1. And then we get this. And x less than negative 1. Is that an and or an or? How can I be greater than 1? I need to be a number bigger than 1, or I need to be a number less than negative 1. Okay, I do need to check the endpoints. So let me organize that over here. Check endpoints. Okay, so x equals, well, let's cross out the answers first, though. Yeah, we do need to check between D and E. Okay, so check the endpoints. So x equals 1. That would be 2 over 1 squared plus 1 to the n, summation. So that's 1 to the n, which is 1 plus 1 plus 1 plus 1. So that diverges by nth term test for divergence. So then it's not 1, so it's not this one. So it must be D. But if I'm taking a free response test, I would have to check the other endpoint. So I'm going to write this in another color so that you can see it, because I believe I'm at the bottom of the page. Oh, I'm not at the bottom of the page. Well, I still like it to be up here. So I'm going to call it last step. I'm going to write this in red. So this is last step, which is so if this is written separately. So I'm checking the other endpoint. So this is 2 over negative 1 squared plus 1 to the n. So that's also 1 to the n. Oh, that's interesting. So it's exactly the same. So this is 1 plus 1 plus 1. Okay, and that diverges by the nth term test for divergence. Remember, that test says that if the limit as n approaches infinity of an, let me erase the absolute values, of an is not 0, then this diverges. This is the nth term test. sounds good. Let's see. So I never really use this part over here. Oh, it makes sense. This part over here, I wonder if I have a highlighter. Oh, okay. Let's see if this highlighter works. So this spot right here. Oh, okay, but I don't want gray. Oh, I have to press yellow. Okay, hold on. Can I erase? Okay, good. So let me use the yellow. So this part right here, okay, this part right here before I absolute valued it is always positive. So the part over here, I'll kind of put an X through it. When is a positive greater than -1? Well, it's always greater than -1. So I didn't really need to write that part. So I didn't really need to write this part either. So I kind of like this way better. I like my flipping way. This is my favorite way. I feel like this way makes sense. Okay, and then I would check the endpoints. Here we go. Check the endpoints. And then I did this part. So I would say that's my final choice on what I did. How did I know it was geometric? Well, let's see. I'll write this in orange. It's geometric because it's, oops, oh, I'm still on the highlighter. Oh, that's funny. Okay, so let's see which one the pen is. Probably that one. Okay, that's funny. Okay, let me erase that weird highlighter. Okay, so, and let me be on another color here. Blue, I guess. Okay, how did I know it was geometric? Oh, that's too thick of a blue. Okay, so this is 2 over x squared plus 1 plus, that was n equals 1, n equals 2, looks like this. N equals 3 looks like this. So to get from one to the next, it looks like r equals 2 over x squared plus 1. So, I don't know. I feel like the ratio part of the rule, I mean the geometric part of the rule was a little strange, but I like the nth root test. So I would say one more time on the highlighter. Let's see if I can get the highlighter. One more time on the highlighter is I'm going to say I like this part, I like this part, but then I would go up to here. Okay, then I would go up to there, and I probably wouldn't do the R thing, so let's erase the R thing here. Okay, there we go. So I think that's what I would do. Okay, anyway, but it doesn't matter however you solve it, as long as it's right. You'll get full credit. Okay, let's see 17. I think we have time for 17. Let's see. Let's get our colors back going. Blue. There we go. Okay, it's differentiable. That means I'm allowed to take the derivative. Here we go. Okay, so f of x equals h of x squared minus 3. I want the derivative. So I'm going to do h prime of the inside, keep the inside, multiply by the derivative of the inside. And then they want f prime of 2. So f prime of 2, they want to substitute the 2 in. And that's h prime of 4 minus 3 times 4. H prime of 1 times 4, which is 4h prime of 1. Huh, B. Okay, that was kind of a nice one. Nice ones, crazy ones. We have all sorts. That's the end of that page. So let me go to the next page. See what number 18 looks like. I love these questions. I'm so weird. Okay, that's an AB question, I would say. What about this one? That's definitely a BC question. But that's an AB question. Okay. Let's see. In the xy plane, that's a line where k is constant, tangent to the graph. Okay, tangent to the graph, there's two facts if something is tangent to the graph. That means they share the slope. Okay, and you know that. But they also share a point. Okay, so sometimes people forget that they share a point, and I have a feeling this is a question like that. So say you had some crazy line shape, and it was tangent to the graph. Right at this point, A, the y value is shared, and the slope is shared. Now, if it said it was parallel, then that would just mean the slope. So tangent actually means they share a slope and they share a point. I'm going to make my pen a little skinnier. Okay, so when I look at these two, I'm thinking both things need to be true. So I'm going to change this into y equals mx plus b. Oh, let's see. So this is y equals, subtract x from both sides, negative x plus k. Okay, so my slope here of this one, my slope is negative 1. And this one, my slope, y prime, is 2x plus 3. And I did the slope, y equals mx plus b. But you could also do y prime equals negative 1. You could also take the derivative. That works both ways. Okay, then I took the derivative of the quadratic over here. Y squared equals 2x plus 3. And it says it's a tangent. So that means the slope are going to have to be the same at some point A. So sometimes it's helpful to call this A f of A, and then the slope is f prime of A. So that's possibly helpful. I'm thinking that we should do that just to clean up the, to make it clear. Okay. I don't know. Let's just set the slopes equal. So the slopes are equal, but they're only equal at one point. Okay, and they're equal at this point, 2x equals negative 4, which is x equals negative 2. I guess this is okay. So A is my negative 2. So at negative 2, okay, so at negative 2, the slope of the quadratic is negative 1, and the slope of the line is negative 1. So we've made their slopes the same. But we didn't say that line was parallel. We said that it was tangent. So that means they're going to also have to share the same y value. Now, the only y value we know at this moment is the quadratic. So this one is y equals negative 2 squared plus 3 times negative 2 plus 1. So that's 4 minus 6 plus 1, which is negative 1. That's kind of annoying that the slope is the same. But it is. Okay, so the slope is the same coincidentally. Which means, I'm going to do this in another color in red, I need this one's slope of my line, or my y value of my line, to also be negative 1. Okay, so I need it to be for my line. This was my line, and this was my quadratic. Okay, so I need both of them to have the same y value, which means that this point has to make this equation true. So I'm going to say that x plus y equals k. My x is negative 2. My y is negative 1. So k must be negative 3. So k is negative 3. Interesting. There's a really complicated question that you guys saw last year that looked like this. I'm trying to free response all of these for this year's test, the 2020. This definitely could be a type of question within, but I don't think it would be phrased exactly this way. But the word tangent is important. Okay, so tangent does mean they share a slope and share a point. So that's definitely possible. There is something that came up once. We'll put a what if. They've used the word secant line before. Okay, so a secant line, that's actually 2 words. Okay, a secant line, it's not really applicable to this problem, but just so you could see the difference between a secant line. Say you had a parabola. Okay, say you had a parabola. A secant line goes through 2 points, and a tangent line just goes through 1 point. Okay, but a secant line specifically, it sounds so scary, but really it's 2 points, and then you need to find a line. So imagine if you had A, B, C, D, and you were trying to find the equation of a line. Isn't that what we did in Algebra 1? So secant lines have 2 points. So you would use the slope formula, y2 minus y1 over x2 minus x1, and then you would use your point slope form, y minus y1 equals m parentheses x minus x1. Let's see. This one, that one's going to take me a little while. So let me wait on this one until the next video.